Hello everyone and welcome to week 7 of COMP-111. All right, so as it tells you here, we're going to discuss loops and sentinel values. All right, so loops are another word to refer to loops would be repetition structures. So what it does is it allows code to be repeated as long as a specific condition remains true. So we talked about decision structures where if this decision is true or if this condition is true, then execute these statements. The same sort of scenario falls true for loops where if this condition is true, then execute the statements that are in the body of the loop, then go back up and check the condition again, and you're going to keep doing that, looping, redoing that, check the condition, execute the statements, check the condition, execute the statements until which point as the condition is no longer true. Now there's two categories of loops that we're going to be talking about: condition controlled and count controlled. Theoretically, a count controlled is condition controlled, but there's a slight different variation on how they're specified. All right, so the components on a loop, and this is the same whether it's condition controlled or count controlled, is set the initial condition. So you'll set something to false or set your counter to 0 depending upon what you're doing. Then you're going to test for the condition. Is it true? Is this condition true? In which case, execute the loop. You're going to then execute the body of the loop. So these are the statements that need to be repeated in the loop. And then you need to provide a way to change the condition. And that last statement is incredibly important. You have to provide a way to change the condition, or you end up with what's called an infinite loop. Your loop doesn't have any way to stop, and it just keeps executing, growing tighter and tighter and tighter until eventually you either have to cancel the program or your computer crashes, one or the other. All right, so as far as the different types of loops, so remember we have categories of loops, which is condition controlled or count controlled, and then within those categories we have types of loops. So the while loop and the do while loop, these are both condition controlled. So the while loop says keep looping while the condition is equal to true. Okay, so keep looping as long as our condition equates to true. The do while loop, on the other hand, says I want you to execute the body of the loop first and then check the condition and then keep going as long as the condition is true. All right, a for loop is a count controlled loop, and this says I want to execute for a specific number of times. All right, now on the while loop, I just want to go over this. A while loop can execute 0 to many times. If the condition is initially false, then the while loop will never execute at all. Okay, but it could execute 0 to many. A do while loop is going to execute 1 to many, so it's going to definitely do the body of the loop first, and then it's going to check the condition, and then each iteration after that, as long as the condition is true, the loop will continue. A for loop, as is the case of the while loop, could execute 0 to many times. If you specified a number or condition that would equate to 0 right off of the get-go, then it won't execute at all. Okay, so while and do while are condition controlled. For is count controlled, and the while and the for can execute 0 to many times, while the do while will execute 1 to many times. Okay, now here's the format for specifying a loop. It's while with a space, and then you're going to have your open and closing parentheses, and inside the parentheses will be the condition of your loop. We then have the curly brackets that fall underneath the while statement, and inside of those curly brackets are going to be the body of the loop, or the statements that you want to repeat. And so here's an example. We set our condition. Remember, it's set the condition, test the condition, the body of your loop, and then provide a way to change the condition. So here we're setting our condition, x is equal to 0. The condition that we're testing is as long as x is less than 10, we're going to continue to execute. Inside the body of the loop, we print out the statement x is equal to, so we're printing out the value of x, and then we provide a means of changing the condition by incrementing x by 1. Okay, so what this will do is it'll say x is 0, 0 is indeed less than 10, so let's print out x equals 0, and then we increment x, it now equals 1. 1 is less than 10, we print out x equals 1. We increment x, it's now equal to 2, and we keep doing this until eventually x is no longer less than 10. Now, one thing to note here, there's no semicolon here. Okay, the semicolons follow the body, or the statements that are within the body, and of course your initialization outside of your loop. But there's no semicolon here. If you were to accidentally put a semicolon right here, this becomes your entire loop. Just the while statement is your loop. And this actually becomes an infinite loop because x will always be less than 10. It's initially set to a value of 0. It is less than 10, and because this is your whole body of the loop, because of the semicolon right here, there's no way for x to ever become not less than 10, and so this particular statement just keeps executing over and over and over again, and so this would be an infinite loop. All right, the do while loop. So again, remember the format of the do while loop is to execute everything once and then check the condition. So here's how that works. You say do, and then you have your open and closing curly brackets here, and these are the statements or the body of your loop. And then you have while with your open and closing parentheses and a condition. And in this case, you would do a semicolon down here to terminate, to show where the do while loop ends. And so here's an example of how that would look. Again, set the condition. So it doesn't matter if it's a while loop, a do while loop, or a for loop. These things are always happening. So set the condition, do, open and closing curly brackets. Here's the body of the loop. We provide a means to change the condition, and then we test the condition down at the bottom. So what will happen here is x is equal to 0. We're going to print out x is equal to 0 first, then increment x, it's now 1, and then check the condition down here. And as long as it's true, come back up here and continue this over and over again until eventually the condition is false. All right, the for loop. So the for loop is considered your count controlled loop. And what they did with the for loop is they said, you know what, people are going to be doing this all the time, right? They're going to be doing these count controlled loops, and we've got these steps here: set the condition, test the condition, change the condition. We know those three things have to happen every single time. And we know that they're going to be doing these counting type loops, you know, process all the students in a class. There's 30 students in the class, do it 30 times, you know, that sort of thing. So what they did is they developed a special construct that puts all of those components up in the header part of the loop. And so here's how that looks. It's for, and then you're going to initialize your variable with a semicolon. So this is one statement: initialize your variable, semicolon, your condition, semicolon, and then how you're changing your value, whether it's an increment or decrement. And then you have your open and closing curly brackets, and then the body of your loop inside of those. So here's how that might look. We say for integer I equals 0. We're actually initializing the value of I, so that's why we're including the data type. So remember, before with the while loop, we did that, or even in the do while loop, if you look here, we initialized up here at the top, right? Here we're doing it right in here. Then our condition is I is less than 10, and then we're incrementing here I++, and the body is print out the value of I. So here we have set the condition, test the condition, change the condition right here. Okay, now a for loop and a while loop, remember the while loop is considered condition controlled and a for loop is considered count controlled, but they can both execute 0 to many times. The reality is a for loop is just a shortcut way of writing a while loop. So for loops can always be written as a while loop. The reverse is not true. Some while loops can be written as for loops if they are indeed counting, but some while loops are more user controlled, where they're letting the user set a value, in which case you cannot write it as a for loop. But let's compare these two side by side. So we have our while loop here. We're setting our condition. So setting our initial variable, so I equals 10. And inside the for loop, we have integer I equals 10. Then we're testing our condition, right? I is less than 100. And here's where that goes in the for loop. I is less than 100. And then we're incrementing our value of I. We're changing our condition. I equals I plus 10. And here we're doing it I plus 10. And then we have our body of the loop as well. So you can always rewrite a for loop as a while loop. And again, the vice versa is not always true. Okay, so how do you know which loop to use? Well, you need to just kind of ask yourself some questions. So you know the while loop and the do loop are condition controlled. So the question is, do you know specifically how many times your loop is going to iterate? Like, is it a known entity? It's going to iterate 30 times or 20 times, or is it something the user may be determining? Like, for instance, you're asking the user, do you want to loop again? Do you want to process again? And if they say yes, you do. And if they say no, you don't. Well, in that case, you don't know how many times you're going to loop, right? The user is in control. It could be 5 times, 4 times, 2 times, 100 times. So that would be condition controlled versus count controlled. If you specifically know how many you're going to loop, then you're going to go with a for loop. But if you don't, you're coming up here and looking at a while or do while. The next question to ask yourself is, do I need to execute everything first and then check my condition, or should I check my condition first and then do my loop? And so that is also determining if it could execute 0 to many times, you need to check your condition first before you do any looping. That's going to be a while loop. This is what's called, it's condition control, but it's also called a pre-test. You test the condition before you do any looping. That's the same, the for loop as well. Pre-test. You test the condition before you do any looping. If you do need it to execute at least one time, that's going to be a do while loop. This is considered a post-test. You execute everything once and then you test your condition. Okay. All right, so I've got a couple examples here. So we're balancing the checkbook, and we're going to keep going until the user says all of the checks have been entered. So what kind of loop would this be? Would this be a while loop, a do while loop, or a for loop? So the big thing we have here is keep going until the user says all checks are entered. That means we don't know specifically how many checks there are. The user is controlled or in control. So that's definitely condition controlled and not count controlled. The second thing we have here is there may not be any checks, right? So we don't know for sure that there's one check that has to be processed. There could be 0 to many checks. So in that case, the while loop would be the best choice. It's condition controlled, it's pre-test. So you're going to go with the while loop here. Entering exam 1 grade for X number of students. Well, we know specifically how many students they are, and we're entering a grade for them. So this is going to be a count controlled loop. Okay, it's count controlled, pre-test. There may not be any grades yet received, so there's none to be entered, but we do know specifically how many students. So this is going to be a for loop, a count controlled loop. Prompt the user to enter their registration information and then ask if they need to register someone else. So in this case, this is going to be the user's in control. They're going to tell us if we need to register additional people. So we don't know specifically how many people are going to be registered. So this is going to be a condition controlled, so either a while loop or a do while loop. And in this case, we're telling them, here, enter your registration information, and then we ask them if they want to register someone else. So this would be a do while loop. We're going to first prompt them to get all their registration information, and once they've entered it, then we're going to ask them, do you need to register someone else? And if that's a true situation, then we'll go back up and prompt them again. So this first one is a while loop. It's condition controlled. The user's in control here. We don't know specifically how many times. The second one is a for loop. We know for X number of students, so we know specifically how many times we're going to iterate. And this last one is a do while. We're going to do it at least once and then repeat based upon what the user tells us. All right, infinite loops. All right, so do not beat yourself up if you generate an infinite loop. We all do it. I still do it on occasion, all right? Infinite loops happen. And what an infinite loop is, the condition never equates to false, so there's no way for the loop to end. Okay, what ends up happening is you'll end up either canceling, closing down Blue Jay, or your computer crashes, so you restart. They just keep running and running and running and getting tighter and tighter and tighter until eventually something crashes, okay? So here's an example. Integer x equals 10, so we've initialized our condition variable to a value of 10. We say keep going while x is greater than 0, and 10 is indeed greater than 0, so this condition equates to true. And then our means to change the condition is we add 1 to x, which means x is then going to be 11 and then 12 and then 13 and 14. So x will never be less than or equal to 0. So this is an infinite loop. It will, once it starts executing, it will never stop. All right. Nested loops. So you can put loops inside of loops, all right? So we can have an outer loop and then an inner loop depending upon what we need to do. So here's an example of a problem. We want to print X number of asterisks on a row for Y number of rows. Okay, both of these involve counting X number of asterisks, Y number of rows. So those are both going to be a for loop. Our inner loop, we're going to print the asterisks. We know that we're going to print X number of asterisks, but maybe the user is determining how many asterisks those are. Okay. So we don't know specifically it's 5 or 6, so we can't just do a line of 5, right? The outer loop is the number of rows, and again, the user is going to tell us how many rows, but once they've told us it's a set number, it's not going to change. All right. So here's how that might look. So we ask the user, how many asterisks do you want me to print? And they tell us, and we store that in this variable num asterisk. So whether they've entered 5 or 6 or 100 or whatever, we've stored that number of asterisks. And then we ask them, well, how many rows do you want me to print? And they enter that value, and we store that in our variable num rows. So these are known quantities because we have it stored in num asterisks and num rows. So we specifically know, the computer specifically knows how many times we want to loop. We as users can't say that that's number 4 or number 7 because we don't know what the user entered, right? But the computer knows because it's stored in our variable. All right, so then we generate an output variable, string output, and this is where we're going to put what we build, okay? And then we have our outer loop. I equals 0, I is less than the number of rows, and we're incrementing by 1. So we're going to keep going as long as we haven't exceeded the number of rows that the user indicated. We set our output equal to nothing. We clear it out, okay, just to, not even a space, just to, it's not a null value, but it's a nothing value. And then we start our inner loop. J equals 0, j is less than our number of asterisks, and then we increment j by 1. So each time through the body of the loop, we set output equal to the output plus an asterisk. So we're adding one more asterisk on each time through the loop. And when this inner loop ends, then we're going to print out what we stored in output. And then we're going to go back up for the next row and start the process all over again. So what this ends up looking like is our output is initially, so we come in, so let's say we have 3 rows and 7 asterisks, okay? So we come in, I is 0, I is less than 3. So we set our output variable equal to just this empty string, right? Then we come in here, j is equal to 0, j0 is less than 7, so we're going to go ahead and execute the loop, and we add an asterisk to output. So now output contains 1 asterisk, and we'll come back up here, and j is now equal to 1. 1 is less than 7, so now output contains 2 asterisks. J is now 2, 2 is less than 7, now output contains 3 asterisks, and so on until eventually output contains 7 asterisks. At that point, 7 is no longer less than 7, so the loop ends and we print out the contents of our output. We print out 7 asterisks, okay? We come back up here to I was originally 0, I is now equal to 1. 1 is less than 3, so we again clear out our output, set it equal to just an empty string, and then we start all over again. J is equal to 0. 0 is less than 7, and we build another output string of 7 asterisks. We finish that up, and we print it out, and we come back up here. I is now equal to 2. 2 is less than 3. We come inside, initialize our output to nothing, start this loop all over again, build our output of 7 asterisks, print it out, come back up here. Now I is 3. 3 is not less than 3, so we're all done. And we would have had 3 rows of 7 asterisks on each row. I encourage you to take this and copy this code and paste it into BlueJ and experiment with it. Enter different values on the console, see what you end up getting, maybe even tweak some stuff in here and see what happens so that you can really become comfortable with not only for loops, but also nested for loops. Okay, now here's another nested example. This is actually going to incorporate a do-while loop and a for loop together in the same example. So here we have a problem. So if you're a runner or a bike rider or whatever and you participate in any races, this is a real common thing. So we're going to register teams for a race. The number of teams we know for sure is one, but it could be one to many. And there's going to be X number of members on each team. So we will always register at least one team. So that's going to be a do while loop. It needs to execute at least one time. And we know they're going to enter X number of members on their team. So that's going to be a for loop because the number of members is known. All right, so let's take a look how that might look. So we have do here. What is your team name? And we accept that from the console. We use the next line because the team name could contain spaces, right? And if we just use the next, it would only retrieve it up to the first space. So we're going to use next line just in case our name has spaces. And then we're going to ask them how many members are on your team. And we're storing the number of members inside this variable num members, right? And we use the next integer because you're not going to enter half of a member, right? So a whole number. And then we loop for I equals 0, I is less than num members, I plus plus. And so we say enter the member name, enter the gender, enter the age. And I did not include the input statements because this got really small. So assume that there's input statements here and we would retrieve all that information. And then when we're done with the for loop, we come out and we say, do you want to register another team? Yes or no? And we accept that from the console. And if they entered yes, then we'll come back up here and prompt them again. What's your team name? How many members are on your team? And we'll get all the team members. And we'll keep doing that until eventually they say, no, I don't want to register another team. Okay. So again, I would encourage you to copy this code right here. You can input or insert the input statements here for the different team information and just play around with this and experiment with it and see what you get and how it works and what do how are things going. Now you may be asking a question here. Let me go back to this previous slide here. You may be wondering like why I equals 0 and J equals 0. That's just really a convention in Java. It doesn't have to be I and J, and then you would even go to K if you were in a third triple nested loop, all right? It just seems to be a convention that was used. To do, if you're doing a for loop, you use I and then J and then K. I don't really know the rhyme or reason behind it, but that's just a common naming convention in Java, but it doesn't have to be. If you wanted to call this counter, you could set integer counter equals 0, counter is less than num rows, counter plus plus, and that would be perfectly acceptable as well. But if you want to go with I, J, and K, that's fine too. It's kind of a Java naming convention, so you'll see that all the time. All right, a sentinel value. So what comes to mind when you think of sentinel? I usually get a lot of things when I ask that question in a live meet session. So I'll usually get, like the X-Men, the Sentinels there, or maybe there's a basketball or soccer team or something called the Sentinels. I know whenever I think of it, I always think of the palace guards at Buckingham Palace with the big, huge hats that never smile, right? But a sentinel value in Java, it's kind of the same thing. It's a guardian on your loop, and it helps you determine when the loop should start. So it's this value that triggers to the loop that it's time to stop. And this is typically set by the user. So in the previous example, when we were saying, do you want to enter another team? And the user said yes or no, that's our sentinel value, is the user responding with either a yes or no. So if they responded with no, that would be our sentinel value. Now, typically, this could be a Boolean value here, and so we might do Boolean keep looping equals true. So we've initialized the variable keep looping as data type Boolean, set it to a value of true. So we say while keep looping, so as long as our keep looping variable contains a value of true, we're going to continue going. And then here, do you want to keep looping, yes or no? We take in the answer. If they entered a no, then we just set keep looping to false. In which case, when you come up here, keep looping is no longer true and the loop will stop. Now, a couple things I want you to just note here is one, I'm doing keep looping, just while keep looping. I don't have to do while keep looping equal true, because keep looping is a Boolean and your conditions equate to Boolean. So since it's already Boolean, it already contains either a value of true or false. Okay, so we can just say while keep looping, and if it contains a value of false, it's false, so stop. If it contains a value of true, it's true, so keep looping. All right. The second thing here is the answer that got entered by the user, enter yes or no. Really, we could just say enter no, and we don't care what else they enter, right? But when I'm checking the answer, I'm doing an equals ignore case. You just never know how the user is going to enter their value. They might enter capital N, lowercase o. They might enter it all in caps, all in lowercase. So I just took all of those different possibilities out by just saying ignore the case altogether. I guess the third thing I want you to note is, do you want to keep looping? Enter yes or no. I specifically tell you what to enter, right? I want you to either enter yes or enter no. I would probably change this to say enter yes, and I would only look for a yes value or something like that. You don't want to make the user guess. You want to tell them specifically what it is that you want them to enter to stop the loop. Otherwise, if you don't tell them what they need to enter and they can't figure it out, that's essentially an infinite loop. You have provided no way for the user to get out of the loop. So that becomes an infinite loop. And so you really want to be specific. You want to tell the user how they can exit that particular loop. Okay, accumulating totals. This is really common, something you're going to do all the time in programming. So the algorithm for accumulating totals, so the basic format whenever you're doing this, is set your total variable to 0 or to whatever condition you need it. If you're starting with a value of 100, for example, you might set your total variable to 100, but typically you're going to set it to 0. Then you're still going to set the condition and test the condition for your loop. You're going to have the body of your loop, and then somewhere in that body you're going to add to your total variable, and you're still going to change it. When you exit the loop, you can then print your total. And this is how this could look. So we said double total equals 0. We ask them, how many checks do you have? And then we accept that input from the console. We're going to keep looping as long as our I variable is less than the number of checks. And then we're going to print, enter your check value. We accept that from the console. And then here we add our check value to the total. And then we print out your total check values equals. And then we do that at the very end. Now, it just dawned on me that some of you may be going, I equals 0, I is less than check. Shouldn't we say less than or equal to the number of checks? Well, it all depends upon what you initialize your I variable to. If I've set it to 0, then I want to go I is less than the number of checks. So let's just look at that. So if I is equal to 0, and I'm going to keep going as long as I is less than the number of checks. And let's pick a low number. Okay, number of checks is 3. So initially I is 0. 0 is less than 3, so that's processing 1 check. Now I contains a value of 1. 1 is less than 3. We've now processed 2 checks. Okay, and then we'll set I equal to 2. 2 is less than 3. We've processed 3 checks, and that's how many checks we were supposed to process. I is now equal to 3. 3 is not less than 3, and we're done. So if I had actually said I equals 0, I is less than or equal to the number of checks, I would have tried to process 4 checks, 0, 1, 2, 3, which would have been 4, 0, 1, 2, and 3. That's a total of 4 checks, as opposed to the 3 that I wanted. Now, if it makes more sense for you to do it that way, then what you want to do is you want to set your I equal to 1, and then you can do I is less than or equal to the number of checks. Okay, if we started with 1, we would process check number 1, then we would process check number 2, we would process check number 3, and when I then contains a value of 4, we would stop processing. So it's whatever makes the most sense to you. You can start I with 0 and then do a less than, or you can start I with 1 and do a less than or equal to. Okay, whatever makes the most sense to you. I'm just in the habit of starting with 0 because, you know, your strings start with 0, your substring, you know, everything else starts with 0. So I'm in the habit of doing that, but you need to do what makes sense to you. And again, I encourage you to take this code and copy it and paste it into BlueJ and experiment with it and see what happens, and maybe change this to I is is less than or equal to and see what you end up getting, or set I equal to a 1 and, just change things around and experiment and see what you end up with. All right, an average. So this is also something that's very, very common. Okay, so first off, to compute an average, you need to know how you compute an average. And an average is computed by the total divided by the number of items that made up the total, right? So if you're adding 10 items together, you're going to do the total of those 10 items divided by the number of 10. And if there were 5 items, it would be the total divided by 5, and so on. So here we set our total equal to 0, and we ask how many checks there are. That's going to be the number we're going to divide by, right? We accept our number of checks from the console, and then we loop through. Again, I equals 0, I is less than the number of checks, adding to our total. Okay. Now when we come out, before we can do any division, we have to check. Is our number of checks greater than 0? If you try to divide by 0, you can end up with a runtime error, a divide by 0 error. Because the person may have said, I don't have any checks. No checks this month. Nothing to balance, in which case this loop never executes. So our total is 0, our num checks is 0, and then you come down here, and if you do the division, your program crashes with a runtime divide by 0 error. So whenever you're dividing, you always need to check your divisor to make sure that it is not equal to 0. So I check num checks greater than 0, and then I compute the average equals the total divided by the number of checks. Now, again, we have to be careful about integer division. So my total is defined as a data type double. Remember, an average can always end up with a partial, right? There can always be decimals with an average. So you want to make sure that you're going to get decimal division, not integer division. So my total is a double. So that will work fine. My num checks is an integer, so I would need one or the other to be a double. My total is a double, so I compute my average here, and then I can print out my average is and whatever that computed average would be. And again, I encourage you, copy this code, paste it into BlueJ, enter some values in, like ahead of time, know what you've got. Maybe you do, enter 3 and 7, which would be 10, so the average would be 5. You have 2 checks, one's for $3, one's for $7. You know the average is going to be 5. See what you get. Enter those values in. Take off this check for greater than 0 and just compute the average, and then enter a value of 0 and see what happens. Check out that runtime error that you get when you do that. Just experiment with any of the code segments that are in this PowerPoint here. Copy them, paste into BlueJ, manipulate them, enter values, see what you get, right? That's the best way to learn how all this stuff works. All right, and that brings us to the end of loops and sentinel values, and we will see you next week.